Heat transfer can be defined as the process by which there is a transfer of energy from one location to other. This transfer can be caused by various mechanisms like conduction, convection, and radiation. In this video, we will show you two mechanisms of heat transfer. First, conduction of heat transfer, and second, the radiation of heat transfer that occur in our daily life. Conduction can be defined as the transfer of energy from a high temperature region to the lower temperature region. Heat conduction experiment. The objectives of these experiments are to examine the temperature profile and determine the rate of heat transfer resulting from radial heat conduction through the wall of a cylinder. Second, to investigate the influence of thermal insulation upon the conduction of heat between adjacent metals. The heat conduction study bench consists of two electrically heated modules mounted on a bench support frame. One module contains a cylindrical metal bar arrangement for a variety of linear conduction experiments, while the other consists of a disc for radial conduction experiment. Both test modules are equipped with an array of temperature sensors. Cooling water to be supplied from a standard laboratory tap is fed to one side of the test pieces in order to maintain a steady temperature gradient. Computer will display the direct reading of the temperature sensors and power input to the heater for ease of monitoring and data acquisition. The temperature difference across each interface were measured using thermocouple. Using the Fourier law of heat conduction, the required conductivity was calculated. Connect the plug to the power supply. Switch. Temperature selector switch. Temperature reader. Heater power control. Voltmeter reader. The heater supply LED. And the radial conduction module. First, connect one of the water tubes to the water supply and the other to drain. Then, connect the heater supply LED for the radial conduction module into the power supply circuit on the control panel. After that, connect the 6 sensor, which is TT1, TT2, TT3, and TT7, TT8, TT9 LEDs to the radial module with the TT1 connected to the innermost plug on the radial. Rotate the heater power control knob control panel to the fully anti-clockwise position. Then, set the power to the auto position. After that, set the heater power to 20 watts and allow sufficient time for a steady state condition. Then, record the temperature at all 6 sensor points and the input power reading on the wattmeter. This procedure should be repeated for other input power up to the maximum permitted when the temperature is 100 degrees Celsius. After each change, sufficient time must be allowed to achieve steady state conditions. In experiment 2, we are going to investigate the influence of thermal insulation upon the conduction of heat between adjacent metals. For the second experiment, we will use a linear module that consists of heater part and cooler part, brass conductor, two types of insulating material which are paper and cork. First, make sure that the power is in the off position. Then, insert a brass conductor about 30 mm diameter section into the linear module and clamp together. After that, place an insulating material in between the specimen section and cold section. Then, connect one of the water tubes to the water supply and the other to drain. Connect the heater supply LED for the line conduction module into the power supply socket on the control panel. Then, connect the 6 sensor LEDs TT1, TT2, TT3, and TT7, TT8, TT9 to the plugs on top of the linear conduction module. Then, rotate the heater power control knob control panel to the fully anti-clockwise position. After that, set the power to the auto position. Set the heater power to 20 watts and allow sufficient time for a steady state condition. After that, record the temperature at all 6 sensor points and the input power reading on the wattmeter. Lastly, this procedure should be repeated for other input power up to the maximum permitted when the temperature is 100 degrees Celsius.
Now, we want to cook this porridge using the microwave to apply the heat transfer via radiation. Now, I want to insert this ingredient into this microwave. Heat it up until the high temperature and let it be in 20 minutes.
A microwave oven does emit thermal radiation to heat up food. Microwave radiation is thermal radiation. All frequencies of the electromagnetic spectrum carry energy from radio waves, microwave, infrared wave, visible light, ultraviolet, and X-rays to gamma rays. All frequencies of radiation heat up an object that they strike and therefore can be thermal radiation. When physicists use the term thermal radiation, they either mean radiation that has the ability to heat up an object it strikes, or they mean a broad spectrum of frequencies with a certain shape that depends on the emitter's temperature. The higher the temperature of a glowing body, the more the peak in the spectrum of its emitted radiation shifts to higher frequencies. Thus, by looking at the relative strengths of different frequencies in starlight, astronomers can determine the star's temperature.
Assalamualaikum. Hi everyone. Today we are going to investigate the heat transfer by radiation. So currently we are using two colors which are hi, black. Hi, I'm white. These are the two colors. Yeah, I've got two materials here which are the black paper and the shiny aluminium foil. So I'm going to cover them up with the black paper first. So this is not as easy as I thought. Oh, hold it. Thank you. This looks like a chef, right? Somehow. Give it back. Thank you. Ta-da! Okay, now we will leave them for about 7 to 8 hours under this hot sun. We will see.
Well, now let me see what happened after 8